Okay. Welcome back, students. Am I audible? Okay. Uh, the next topic that we'll be going through, the next topic that we'll be studying is filtering of long data sequences. Okay. Now, is the title visible on the board? Somebody, anyone, unmute your mic and please answer me. Is the title visible? Okay. 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 Now, why do we separately study filtering of long data sequences? Is like I said in the previous class, till now, the maximum number of samples or the maximum length of the sample that we consider to obtain DFT or IDFT was n equals to 8, either in the first module or in the second module while studying how to use DFT in linear filtering. Okay, but this 8 is a very small number compared to the length of the sequence that is produced by a real-time signal to analyze or to process the real-time signals. Okay. Now, just to give you a brief comparison, the analog phone, human voice, the maximum range a human voice can take is 20 to 3.8 kilohertz. Now, this is the spectrum. This is the spectrum between which humans can produce the voice. That is from 20 to 3.8 kilohertz. Okay. Now, just to round it off, instead of 3.8 kilohertz, we'll be using 4 kilohertz. Okay. Now, if this is the maximum frequency component in the analog signal, which is human voice, then it has to be sampled with at least twice the maximum frequency component. Okay, and that sampling rate, the twice of this will consider at least twice. Okay, so twice of this will be 8 kilohertz. Okay, so 4 kilohertz continuous time signal or analog signal, which in this case is an example for human voice, will be sampled at a frequency 8 kilohertz. 8 kilohertz. Okay, now what do you mean by these 8 kilohertz? This means we'll be having 8,000 samples. 8,000 hertz is also 8,000 samples per second. Okay, that means in 1 second, sampled version, in 1 second of sampled human voice, we'll be having 8,000 samples. Okay, 8,000 samples, which are far more compared to whatever we consider now. If we want to operate on 1 second of an audio signal from the human, we will have to process 8,000 samples per second. Okay, which is very far number of samples, far more number of samples than we what considered. Are you all following? Yes? So within 1 second, we'll be having 8 number of samples. If you want to convert this into frequency domain, then we'll have to apply DFT. If we use matrix method, then we should be having 8,000 by 8,000 20 factor matrix, which will be multiplied to 8,000 samples in the time domain sequence. Okay, which is not practically possible in present day computers. So you can think of the magnitude here. Only for 1 second we'll be having 8,000 samples. Okay, if the audio clip is for over 2 or 3 minutes, it will be the number of samples involved will be very large. Okay, so applying 8,000 cross 8,000 20 factor matrix of generating these many number of values in the computer systems are impossible. Okay, so to when we encounter such practical difficulty, it is always advisable to divide this input sequence with large number of samples in it into smaller subsections and process on those subsections individually. ಅರ್ಥ ಆಗ್ತಿದೆ? Because the processing is linear, we'll be using linear filters. So long data sequences can be divided into smaller sequences, process on them, and the output produced due to those smaller length sequences can be combined together because the operation is linear. Are you all understanding? Are you all understanding? Okay. Now in this section, we'll be studying two methods. First method is called as overlap add method, and second method is called as overlap save method. Overlap add method and overlap save method, basically what they do is they'll divide the longer data sequences, for example like this, into blocks of sequences containing lesser number of samples or smaller number of samples. They'll be processed either by using DFT method or IDFT method or by using linear convolution method. Now the method of evaluation or method of analysis will be will have to do nothing with the division of these longer data sequences into subsections. The only thing is the longer data input sequence will be divided into blocks, and those blocks will be operated on block by block basis. Okay, and the output that are produced due to those blocks of input data will be combined together. So in these two methods, because the rest of the middle part, how to combine the input with the impulse response to obtain the output of a linear time invariant system, either by using circular convolution method or by using DFT and IDFT, we studied in the previous section. So we'll have to do that problem, but mainly we'll understand using these two methods, overlap add and overlap save method, how longer data sequences are subdivided into blocks, subsequences, and how the output produced due to those blocks will be combined back to get the total output of the system. Okay, and in both of these methods we'll be having an impulse response of the system and x of n input sequence. But the difference is this input sequence will be of a longer duration. Okay, and again m will be the length of the impulse response and l will be the length of the input sequence. Now this input sequence x of n will be, like I said, will be divided into different blocks, and each block will be of the size l. That is, out of the total duration of the input sequence, will be taking only specified number of samples to form those blocks. Now how to do them? There are different in both these methods. We'll be going through them one by one. But we consider the condition on the samples and the number of samples in the impulse response, and the input data sequence segmented into blocks of n points. In these we consider L, which is the input data sequence segmented into blocks of L points, will be far greater than compared to the number of samples in the impulse response. Okay, now this condition will be true, that will be going through when we look into a problem. Okay, so with this brief introduction, why we go for filtering of long data sequences, we'll start with the study of our first method, which is called as overlap add method. Overlap add method. Okay. Now in this method, the size of the input data block x of n will be equals to L. Okay, this means from the given input sequence, we'll be taking L number of samples from it to form the input data blocks x of n. Okay, and the size of the DFTs and IDFT that will be using will be n itself. Okay, now this capital N will be known to us. Now the question will be either to use 8-point DFT or 8-point circular convolution or 4-point circular convolution and all. Okay, but or we can obtain N, capital N as 2 to the power M as well. N will be, like I said in the previous class, it will be calculated. The number of DFTs will be easily calculated for N, which will be expressed as power of 2. So in this case, we'll obtain N as 2 to the power M. Okay, where M will be the length of impulse response, H of M. Capital M will be the length of impulse response, H of N, which will be used to obtain the number of DFT points, capital L. Okay, and capital L are the number of samples in the block. Okay. Now to make the length of this impulse response equals to L, will be padding L minus 1 number of zeros, like we did in the previous class. And to make the length of the block of input, which already have L number of samples, to capital N will be padding M minus 1 zeros. Now these two procedures will remain same, like we'll be going through in a moment. But the input sequence x of M, longer input sequence x of M will be divided into blocks or sections of input. Now let us call the first section that will be creating from the longer data input sequence as x1 of n, x subscript 1 of n. Now in this block, we'll be taking L samples from the input, that is x of 0, first L samples, x of 1, so on up to x of L minus 1. First L samples will be taken from the input sequence. Now total there are L number of samples here. Now to make its length equal to capital N, will be padding M minus 1 zeros, because value of N will be taken as L plus M minus 1. Length of the impulse response, length of the input minus 1. So to form an n-point discrete time sequence, which will be the first block, in this overlap add method, first L samples will be taken from the input sequence, starting from x of 0 to x of L minus 1 are first L samples from the input sequence, and remaining M minus 1 will be zeros, which will be appended at the end. Okay, and likewise, second block, to get the second block or to form the second block, the next L number of samples will be taken. Next L number of samples will be, we have considered x of L minus 1 here. The next sample will be x of L plus 1, so on to x of, from x of L to capital L number of samples. Last sample will be at x of 2L minus 1. These are the L number of samples. Next L number of samples from the input sequence, and remaining M minus 1 will be zeros at the end. Likewise, we'll go dividing the longer data input sequences into these blocks till we complete all the number of samples, till we include all the number of samples from the input sequence x of n. Are you all following? Are you all following? Yes? Okay. Now, this is how we divide the longer data input sequence into different blocks or different sections. Now, the impulse response h of m will be having m number of samples in it. So we'll retain those m number of samples h of 0, h of 1, so on to h of m minus 1. Okay. Now to make the length of this impulse response to n, will be padding l minus 1 zeros. Will be padding l minus 1 zeros to make the length of the impulse response equal to capital N. Okay. Now after dividing the input and extending the length of the impulse response to n, will be applying n point DFT. Now, after this, the method will be depending on the application. If we need to use the endpoint DFT, we'll be taking the endpoint DFT of these sequences, or we'll be using circular convolution. Okay, we'll be going through that while we'll be solving the problem. Okay, but if we take endpoint DFT of each of these sequences will be calculated. That is x1 of k, which will be endpoint DFT of the first section or first block of data. X of 2 will be the endpoint DFT of the second block of data, and h of k will be the endpoint DFT of this impulse response. So we'll be multiplying each of these according to the convolution property of the discrete Fourier transform to obtain the product DFT. So xm of k, which is generalized subscript values, h of k, n-point DFT of the impulse response, will be multiplied with the n-point DFT of these input data blocks or input data sections. Okay. For each of them, for x1 of k, will be getting y1 of k, which will be product of h of k and x1 of k. For y2 of k, the product DFT will be from h of k and x2 of k and so on. On these product DFTs, will be using or will be applying inverse discrete Fourier transform to obtain y1 of n, y2 of n, and so on. Okay, now these are the outputs. Outputs due to sequences x1 and x2. y1 of n is the output due to the input block x1 of n, and y2 of n will be the output due to the input block y2 of n. Now we need to combine these to get the total output y of n. We need to combine these two, or the number of output sequences that will be due to these input blocks to get the total output y of n. Now in overlap add method, the last, remember, how did you form the input? You form the input by padding m minus 1 zeros at the end of each input block. Now, because of these zero padding, m minus 1 zero padding at the end of the input block, in each of these sections, y1 of n, y2 of n, and all, last m minus 1 sample, from the input, from the output y1 of n, will be overlapped and added with the first m minus 1 samples from y2 of n. And this continues. Last m minus 1 samples from y2 of n will be overlapped and added with the first m minus 1 samples from y3 of n, and so on. ಅರ್ಥ ಆಗ್ತಿದೆ? Understood? Any doubts, any questions? In this, how input will be divided into different blocks, and from the respective outputs, how total output will be combined back. Now that is the catch here, because rest of the things, how to apply DFT, how to multiply it with the impulse DFT of the impulse response, and how to apply IDFT on that, we have been doing. But did you understand how input is divided and how outputs will be combined back? Yes or no? let us represent all the procedure that I have explained till now in terms of a block diagram. Okay. So first we'll be having input data. Input data x of n, which will be of a longer duration. Now instead of representing the sample values x of 0, x of 1, x of 2, just look at it as a block of data. Okay, input data will be of a longer duration. Now this longer duration data, input data, will be divided into different sections, will be divided into different blocks of data, and instead of operating on this entire length, entire longer duration input sequence, will be dividing this into smaller blocks, and those smaller blocks will be used to process it. Okay. Now, how many number of samples should be present in the smaller block? Each block will be having L number of samples. Each block will be having L number of samples. So total duration of the input data will be divided into sub blocks, and each blocks will be having only L number of samples from the input data. Okay. Now in this overlap add method, how do we form this block? Now these blocks should contain capital L number of samples itself. Capital L number of samples. Okay. Now for that, to get the first block, or first segment, let's say the first segment is x1 of n. Let's say the first segment is x1 of n. So to form x1 of n, first L samples will be taken from the input. To make its length equal to n minus 1 zeros will be added at the end of it. So total first section's length will be equal to n naught. L samples will be taken from the input, and m minus 1 zeros will be added. Okay. Now this has to be continued till we cover all the samples from the original input. So next m number of samples. Next m number, capital M number of samples. Next capital L number of samples will be used to form the next block of data, and remaining m minus 1 zeros will be added to make its length equal to capital L. And like this, next L number of samples will be taken from the input signal to form the third block x3 of n, and remaining m minus 1 zeros, will be padded at the end. Is this visible? Okay. Now this is how we divide longer data input sequence into smaller blocks. Each block will be having capital N number of samples. Understood? Any doubts? Any questions? Any doubts? Any questions? Yes or no? No. Okay. Now we'll operate on these individual blocks either by using circular convolution or by using DFT IDFT method. We'll be getting the output. Now we'll look into how output data will be combined back. How output data will be combined back together. Now this figure has to come below that, so it will be having a orientation. But I'll be drawing it here. Okay. Now first output block. Okay. Let's say first output block is y1 of n. Now this y1 of n will be the result of x1 of n, either by taking circular convolution between x1 of n and h of n, or by taking DFT of both x1 of n and h of n and taking IDFT of that product. Okay? But, and let's say y2 of n is the block into the second input block x2 of n. And likewise, let's say y3 of n. y3 of n is due to x3 of n. Okay? Now, how do we combine these different output blocks to get the total output y of n? Now, in this overlap add method, as the name itself indicates, because of zero padding, m minus 1 number of zeros were padded in the original sequence, last m minus 1 samples, from the first output block will be overlapped and added Last m minus 1 number of samples from the first output block will be overlapped and added with the first m minus 1 number of samples from the second output block. Is this clear? Are you all following this? Okay. Likewise, next, last m minus 1 number of samples. Last m minus 1 number of samples from the second output block will be overlapped and added with the first m minus 1 number of samples of the third output block. Overlapped and added. Okay, in this way. Next, these m minus 1 number of samples from the third output block, if we have fourth output block, then it will be overlapped and added with the first m minus 1 number of samples of the fourth output block. If not, they'll be retained as it is. In overlap add method, this is how the input will be divided into different sections, and this is how the outputs will be combined back. Artha ಆಗ್ತಿದೆ? Are you all following? Okay. Now the entire thing I have consolidated into the procedure steps. I'll just read out the procedure now. I'll post this material after this class. Then you can go through. Okay. Now basically this procedure will explain what are the different steps, how to divide the input data block, how to operate on them, and how to combine back the output data blocks. Okay. And the first step in the procedure is the number of samples m of the system's impulse response h of n is known. They'll be known to us. Okay. So we decide upon capital M. Capital M will be known. So we decide upon capital M, and this capital M will be taken as 2 to the power m. Okay. So we decide upon capital M, the number of points for which the DFTs are to be computed. These many number of DFT points will be computed. Okay. We choose n as 2 to the power m. The sequence h of n is 0 padded. Now this sequence, impulse response sequence, which is having m number of samples, will be 0 padded, so that the last L minus 1 values will be 0, so that the total length of the impulse response will be equal to capital M. The second step is the input sequence x of n is sectioned into different blocks like x1 of n, x2 of n, and so on. And the length of each of these sections will be L. That is, L number of samples will be taken from the input. To increase the length of these blocks to n minus 1 zeros will be padded at the end of it. Okay. And the third step in the procedure is the complex product. complex product y m of k equals to h of k multiplied by x m of k, just like I had done it before. Now this complex product of two DFTs will be computed. Okay, where x m of k is the DFT of the zero pattern sequence x m of n. Next step in the procedure is, after obtaining the product, we'll take the inverse discrete Fourier transform IDFT of ym of k. Okay, and the last step in the procedure is taking IDFT on these ym of k will give us y1 of n, y2 of n, and y3 of n. Okay, so in the last step, we will combine these together. Now, how do we combine them? The output sequences y1 of n, y2 of n, and so on. The last m minus 1 number of samples are overlapped and added with the first m minus 1 number of samples in the next output sequence, which gives the total output y of n. So these are the steps in the procedure. Did you all understand this? Any doubts, any questions? Huh? Then we'll go to the problems. Okay, we'll solve the problem. Then we'll be able to understand each of these steps clearly. So again, I will read out the statement. Perform convolution, linear convolution between the input sequence and the impulse response by using overlap AND technique, where impulse response h of n is defined as 1, 1, 1, 3-point sequence. M is equal to 3. Capital M is equal to 3, which is defined as 1, 1, 1. And the input sequence x of n is defined as 1, 2, 0, minus 3, 4, 2, minus 1, 1, minus 2, 3, 2, and 1. Okay, so there are total 12 number of samples. 12 number of samples in the input sequence defined as 1, 2, 0, minus 3, 4, 2, minus 1, 1, minus 2, 3, 2, 1. Okay, by using 8-point circular convolution. By using 8-point circular convolution. Okay. Now, how to start with this problem? How to begin with this problem? How to begin with this problem? Okay. We know what is the length of the impulse response, and we know how many point circular convolution has to be used. We'll be doing the DFT and IDFT problem after this. We know what is capital N. Capital N is 8 because we need to apply 8-point circular convolution. And we know what is capital M, which is 3. Now, using this, we can calculate capital M by using the expression n equals to L plus M minus 1. We know the value of L, we know the value of M, we can calculate L. L will be equals to, for n equals to 8 and n equals to 3, L will come down to 6. Okay, now what this means is, from this 12-point sequence, to form the input blocks, L number of samples will be taken from this and M minus 1 zeros will be added to it, to make its length equal to 8. Okay. Now let us write those input blocks here. Let's say the first input block is x1 of n. Okay. Now to form this x1 of n, first n samples will be taken from the input. So first 6 samples, that is 1, 2, 0, minus 3, 4, and 2 will be taken from the input sequence. And last m minus 1 is 3 minus 1. 2 zeros will be 0 pattern. Okay. Now this is the first input block. Second input block, to get the second input block, again the procedure is same. The next L samples will be taken from the input and m minus 1 zeros will be added. We covered till here. First 6 samples were included in the first block. So from this point we will take the samples to the second block. Minus 1, 1, minus 2, 3, 2, 1. Next 10 samples or next 6 samples will be in the second block and remaining L minus 1 zeros will be added. So these are the two input blocks obtained from this input sequence. Any doubts, any questions? Any doubts, any questions? Okay. Now, the impulse response. Originally, it was having 3 samples in it, or m number of samples in it, will be extended to the length of L by padding L minus 1 zeros. L is 6, so 5 zeros will be padded to make its length equal to 8. Okay. Now, we'll have to perform circular convolution between these. Okay. So, because there are two input sequences, we'll be having two output sequences. Let's define them as y1 of n and y2 of n. y1 of n will be circular convolution, 8-point circular convolution between the impulse response h of n and the first data block x1 of n. And y2 of n will be 8-point circular convolution between the impulse response and the second data block x2 of n. Okay. Now perform these circular convolutions. Okay. I have taken, let's keep h of n common because h of n, write the matrix for h of n because it will be common. You can multiply it with both the sequences. Okay. So either you can use concentric circle method or matrix method. Matrix method will be easier, so we'll be going through it. Okay. Now this is an 8 cross 8 matrix used for circular convolution, which has to be multiplied with the first sequence, that is x1 of n, which is described as 1, 2, 0, minus 3, 4, 2, 0, 0. Okay. We'll write that y1 of n here. Multiply these two matrices. First row of this matrix with this column, second row with this column, which will give us the samples in the output sequence. You do these calculations. I'll directly write it here. It will be 1, 3, 3, minus 1, 1, 3, 6 and 2. This will be the output. This will be the output due to first block of the input. Okay, that is y1 of it. Y1 of it. Are you all following? Okay. Now to obtain y2 of n, the same 8 cross 8 matrix has to be multiplied to second input block, that is x2 of n. So instead of this, we use x2 of n, which was -1 1, -2 3, 2 1 0 and 0. If you multiply these two matrices, the second output block will be -1 0, -2 2, 3 6 3 and 1. So these are the two outputs due to these two inputs, x1 and x2. Okay. Any doubts, any questions till this point? Okay. Now, how to combine these two? How to combine these two output blocks to obtain the total output y of n? So to that, what should we do? Because there are only two blocks here, last m minus 1 samples from the first block should be overlapped and added with the first m minus 1 number of samples from the second block. M value was 3, so 3 minus 1, 2 samples. 2 samples from the first block should be overlapped and added with the first 2 samples from the second block. Now to make it easier, we'll rearrange that in that fashion. Y1 of n, which is 1 3 3 minus 1 1 3 6 and 2. This is the first block. Okay. Now below this, we'll arrange the second block so that m minus 1 samples, last m minus 1 samples here and first m minus 1 samples will be overlapped. We'll add them here. Minus 1 0, m is 3, so 2 samples has to be overlapped. Minus 1 0, minus 2 2, 3 6 3 and 1. Now this is the second block, y2 of it. Okay, now these two are to be added so that we get y of it. In the first 6 samples, there is nothing to add, so they will remain as it is. 1, 3, 3, minus 1, 1 and 3. Okay. Here, 6 and minus 1 will be overlapped, so they have to be added together. 6 minus 1 is 5. Next, 2 plus 0. These two samples are overlapped, so those two are to be added together. 2 plus 0 will be 2. And the remaining 6 samples will be retained as it is. 3, 6, 3, and 1. Okay, so this is the total output. This is the total output of a system whose impulse response was h of n and input was x of n. So this is the total output y of n. So how many samples were present in the impulse response? 3 samples. How many samples were present in the input? 12 samples. So output should be having 14 number of samples. If it has to be represented uniquely. Are there 14 number of samples here? Count them. There are 14 number of samples. 2, 4, 6, 8, 10, 12 and 14. So this output is representing this system uniquely in the time domain. If you perform linear convolution between these two, x of n and h of n, the original sequences that I had written here, you will get the same result. You try to verify it. Okay, you verify it for that. Understood? Any doubts, any questions? Yes? know to find out, it is the procedure of overlap and add method. M minus 1. Because what are we doing in the input sequence? Last M minus 1 samples are zeros. Now, because of this zero pattern at the end, in the output block, last M minus 1 samples has to be overlapped and added. You can't decide on this value. This is fixed. So, last M minus 1 samples, M was 3. So, 3 minus 1, 2. Last two samples in the first sequence has to be overlapped and added with the first two samples in the next sequence. Okay, it is the procedure. Yes? Anything else? Anything else? Okay. Now let's move on to the next problem, where we will be using DFT and IDFT instead of circular convolution. We will be using DFT and IDFT. The statement of the problem is find the output y of m of the filter whose impulse response h of m is defined as 1 and 2. Impulse response is defined as 1 and 2. That is, capital M is equal to 2. There are two samples in the impulse response. And the input sequence x of m is 1, 2, minus 1, 2, 3, minus 2, minus 3, minus 1, 1, 1, 2, and minus 1. 1, 1, 2, and minus 1. Using overlap add method by DFT and IDFT. Okay? How to begin with this? In this problem, we just know what is the value of m. Now, how many point DFT has to be used? They have not specified that. So, that is capital M is not given. Okay. Now, to calculate capital M, we have the expression m plus m minus 1. But out of these two variables again, L and m, only m is given. Okay. So, how to decide upon what should be the length of the input blocks? Capital M ಹೆಂಗ್ ಡಿಸೈಡ್ ಮಾಡ್ತೀರಿ? How do you decide on capital M? No. How do you get this number? We just know M, and as I said in the procedure, M will always be power of 2. So 2 to the power M. 2 to the power 2 is 4. Okay, by using DFT and IDFT method, or we could have done this in the previous problem as well, but there it was specified that we need to use 8-point circular convolution. So we did not calculate n by using this method. Okay, but here n is not given. So n by default will be 2 to the power m, where m will be the length of the impulse response. So in this case it is 2. So capital M will be equals to 4. Are you all following? Capital M is 4. M is 2. So can we decide upon L by using that expression? N equals to M plus L minus 1. L will be equals to 3. This means for the subsections, 3 samples will be taken from the input and M minus 1 zeros will be padded to it. Okay, now let us do that here. X1 of n. Okay, X1 of n is the first block of data. To form this first block of data, L samples will be taken from the input, that is 3 samples. 1, 2, minus 1. 3 samples will be taken from the input and M minus 1 zeros will be padded. M is 2, so 1 0 will be padded to it. So this is the first block of data. X2 of n, remaining 3 samples will be taken from the input, that is 2, 3 minus 2. We had covered till minus 1 in the first block. So from this point, 2, 3, minus 2 will be taken, and again, your minus 1, 0 will be added to it. And likewise, we will complete all these samples here. X3 of n, we had covered till minus 2. So minus 3, minus 2, minus 3, minus 1, 1 will be taken, and 0 will be added to it. Next, x4 of n. In x4 of n, the last three samples will be covered. 1, 2, minus 1, and 1, 0 will be added to it. Okay, and lastly, the impulse response. Impulse response is 1 and 2. There are two samples, m number of samples. L minus 1 zeros are to be added. L is 3, 3 minus 1. 2 zeros are to be added to make its length equal to capital M, which is 4. Okay? Understanding? Okay. Now, what should be done next? Next in module? We need to calculate ym of k. Okay. Now to calculate ym of k, now remember this problem we are using DFT and IDFT. DFT, discrete Fourier transform, and inverse discrete Fourier transform. How to obtain the convolution output using DFT and IDFT? For each of these sequences, you need to find the 4-point DFT. Now those 4-point DFTs are to be multiplied with this impulse response to get this product DFT, and on those product DFTs you need to apply IDFT. Okay, this is a bit lengthy procedure, but the problem is very easy. Are you all following? Okay, now you all use the matrix method. Write the 4 cross 4 twin factor matrix, multiply it with each of these sequences. You will get their respective DFTs. You all do it. I'll be writing the results directly, and I'll try to show you how to combine the output back. Okay? So first 4-point DFT will be 2 minus 2j minus 2 plus 2j. So this is the first 4-point DFT due to x1 of t. Likewise, x2 of t, 4-point DFT due to this second sequence will be 3, 4 minus 3j minus 3, 4 plus 3j. Okay, and third 4-point DFT due to x3 of n will be minus 3, minus 4 plus j, minus 1, minus 4, minus j. Okay. Next, fourth 4-point DFT due to x4 of n will be 2 minus 2j. Now this sequence is same as that first sequence, so their DFTs will be same, minus 2 plus 2j. And the 4-point DFT of this impulse response, h of k, will be 3, 1 minus 2j minus 1, 1 plus 2j. Okay, these are the 4-point DFTs of these sequences. Okay. Now, we'll obtain the product. First product, y1 of k, which will be h of k multiplied by x1 of k. H of k is this 4-point DFT. X1 of k is this 4-point DFT. Multiply them together, you will get a 4-point sequence y of k. Okay, which will be which will be equals to 6 minus 2 minus 6j 2 minus 2 plus 6j. Okay, this will be y1 of k. Likewise, y2 of k will be h of k multiplied by h2 of k. 4-point DFT of the impulse response multiplied with x2 of k. 4-point DFT of the second sequence. So y2 of k will be 9 minus 2 minus 11j 3 minus 2 plus 11. Okay. Likewise, y3 of k and so on. Okay, y3 of k will be h of k multiplied by x3 of k. y3 of k will be minus 9 minus 2 plus 9j 1 minus 2 minus 9j. And likewise, y4 of k will be equals to 6 minus 2 minus 6j 2 minus 2 plus 6j. These are the product DFTs. You copy them, and also I will share the material with you. In the next class, we will be looking into the IDFT and how those can be combined together. Okay? Yes, students? Okay. For each of these problems, practice is very important. So practice them. Okay, I'll be discussing the result in the next class. Okay?